Hello, welcome to Complex Chromatography Solutions Made Easy. My name is Matt Orcutt. I am the owner and founder of Resolution Labs. Today's topic, how to replace complex DMPK, ADME, or radiolabeling extraction techniques, otherwise known as punch, homogenize, and extraction of tissue samples. This process can take 4 to 6 hours depending on experience level. We are going to introduce a fully automated SepQuant droplet probe system. We're going to show 1 to 2 minute sample to sample times, an increase in sensitivity, very low consumable costs, a regular surface or 3D surface compatibility, all while being LCMS agnostic. We are actually doing chromatography, so this separates us from other surface sampling or ionizing techniques. Before we get started, the one question I'm always asked, will this system work for me? We came up with a very low cost solution to test this just for you. Let's head over to the lab bench to take a look. So over here at the bench, we have our manual sample setup. Whether you're using a manual sample setup or the automated system, the workflow is the same. In this case, our sample is just a leaf tissue, but if you're using actual tissue, mouse or rat, you will need to obviously keep that frozen, pull it out of the freezer, put it in a desiccator for about 15 minutes before you start doing any extractions. The essence of either of these systems is going to be a proper microjunction. The microjunction touches the top of the surface of the tissue and is penetrated with the solvent that you're going to use. So I get a question a lot of times, what should my solvent be comprised of? Essentially, we tell people to start off with 50-50 acetonitrile water with 0.1% formic acid so that you can penetrate that tissue during the extraction process. As with this process or the automated process, you have the ability to do multiple extractions. Obviously, at some point there'll be diminishing returns where your deposition will just be absorbed into the tissue and you won't be able to do an extraction. So again, the idea is to get that liquid junction between the surface and the needle and aspirate whatever you dispense back into the syringe. We tell people to start off with maybe about 5 cycles, do that, and then make an injection and vary from there. If you're using, or if you have more of a protein, you want a more aqueous solution. If you are having trouble identifying your compound, maybe you want to use a more aggressive solvent and vary that ratio a bit to help you with that technique. So if my column if my compound starts to elute from the column at 75% solvent ratio, then you don't want to exceed that in the beginning. So you kind of have to consider a little bit of the chromatography at hand. So let's take a look at this. I'm going to set up my pre-made solvent here, and I am just going to pre-wet the syringe with a little bit of solvent. Put it into my device, and I can now adjust the height of this. I'm going to actually zoom in here so you can take a better look. So I'm going to try to capture this view best I can. I'm going to lower this down a little bit more to the surface of the tissue. I have my solution, my solvent extraction solution in my needle. And I'm just going to deposit, suck back up, deposit, suck back up, deposit, suck back up, and repeat until you get the desired amount of extractions. Now I'm going to take this and manually inject into our LCMS. Okay, I'd like to go over a little bit of the hardware here of the droplet probe system. Essentially, we got a standard XYZ robot manufactured by CTC Analytics. Very robust, flexible, open architecture. What we love about this system is it does what you need to do and then some. We can run as a standard LC, or in this case surface sampling as a droplet probe system. So on the left side, we'll start with the wash station. We got 2 washes, 2 different solvents, and a waste. We have a calibration device. Essentially, this calibration device gives us an offset from the laser down to the syringe tip, the needle tip. The camera that's used for confirmation on the deposition of the droplet and then aspirating back into the syringe. We got a tray holder, consists of standard holders in the back of 2 ml vials. So those are 7 different positions back here. Then we have 2 different trays for either mouse or whole body rats is an option, or a standard LC plate. We get a valve. We are mass spec agnostic, so there's no need to have a LCMS. In this case, obviously we do not have one, but there is an option. We pretty much have successfully integrated, or not software integration, but hardware integration with pretty much all the major vendors: Waters, Thermo, Agilent, Cyex, all the major vendors we've coupled with. In this case, we don't have any LCMS, so we've left this pretty simplistic. Over here is the handheld controller, which allows you to adjust for positioning, just like a standard PAL. The computer in this case is a laptop. If you want to use your LCMS computer, that's probably recommended. Then down below this bench top right here, we have a scanner.